All right, so let me give you some time. You can take one full 10 minutes and then you can kind of sort this particular question. And since we have already taken some good amount of knowledge from departure in the previous class, I believe you will definitely have some heads around this question as well. Now, one small clue, if you kind of try to pick up this question using departure equation, departure concept, you probably might fumble. So try to go down to basics and draw kind of diagram and see how it works, right? And when you draw a diagram, as I always recommend, try to make it as big as possible, not too big, but then sensibly big as possible. Don't make it small. That's not going to help you because your diagram is small. You need to put so many things into it. At the end of the story, it's going to be a mess, right? So try to make it big as much as possible. I have this distinct advantage of kind of zooming in and out. So if you're drawing on a piece of paper, make sure you have a bigger diagram. All right, so you can take your time and then go through a question, and then we'll come back and do it together. So, all right, yes. So having said that, I am getting a couple of comments in the chat where they have kind of found a weird way out of this problem. We can definitely discuss multiple ways of doing the same question, but let's look at the simplest possible way. So if this question comes for exam, you exactly know how to do it with the least possible time. All right, so the question is, position A is located on the equator on longitude 130 degrees east. So it's on the equator and 130 degrees east. Perfect. Now, position B is located 100 nautical miles from A. Now, let me kind of underline that again, from A, on a bearing of 2 to 5 degrees. True. All right, so they're giving you two different points. The coordinate of one is given, Latin long, which is point A, and the distance and the track towards point B is given. You're asked to find out the coordinate of the point position. So basically, they're asking you to find out the coordinate of the position. Position B, obviously. All right, so I'm a diagram person. Let's put the diagram straight in the picture. All right, so let's draw the Earth. All right, as I said, I can actually zoom in, zoom out, so you have to kind of draw a bigger diagram all the way here. All right, let's now draw the equator because point A as such is in the equator. So generally, I have this habit of marking the north, east, the directions. The moment I draw the Earth and I draw the basic lines like equator and stuff, that kind of gives me a three-dimensional picture of the Earth. Let's put the 130 degree east longitude also in place all the way down here, and that kind of brings us to point A. Right, now I'll tell you why I have drawn this longitude right here and not kind of somewhere around here a bit later, and that is just because of the spatial orientation which I kind of got when I saw the question. All right, perfect. Now, this is point A, and a point B is from A on a track of 2 to 5 degrees, 100 nautical miles away. All right, so let's just get back to our basic mode sheet here. I always love the basic, coming back to basics because it kind of solidifies the knowledge. So let's draw, let's talk about this. The point B is from A on a track of 2 to 5 degrees. True. Now, understanding this particular statement will definitely help you in any upcoming topics as well. If you look at questions from Convergency, students do fumble with identifying these points A and B because they're not really sure about how to place them, right? So this discussion should probably help you, and that is why I particularly thought of explaining this, even though that is not directly connected to this particular question. All right, so what I generally do to make them understand is you know the basic true decimal system, true direction system, sorry, which talks about north being the reference and then east, south, and west in the clockwise direction. So if I take north as 360 or 0, 0, 0, east is going to be 0, 9 or 0, south is 180, and then you have west as 270. All right, perfect. Now the track that is given in this particular question is 2 to 5 degrees. And what I generally do is I always look at this particular point, the from point, which is from A, and kind of mark that at the intersection. Usually I teach using the board, which you can see right behind me, and that is, so what I generally do is I kind of make my students hold their pen, their finger, or their pencil straight there at the point from there where they want to move, and then kind of start orienting and kind of fix the other point. So in this question, point B is on a bearing of 2 to 5 degrees true. Now, talking about this particular true here, it is because this particular value is referenced with true north. Not just that, the true direction system also says that 225 degrees is measured in the clockwise direction. So from the north, that is right here, if you measure clockwise over 225 degrees, you can see it falls somewhere in the southwest sector quadrant between 180 and 270, and therefore the track we are looking at is a track from A, which is right here, in this direction, which is 2 to 5 degrees. True. All right. So if you have this particular understanding, now we know in which direction to actually draw the figure, right? So let's come back to that. See, as I said, I have this advantage of zooming. So in your case, make sure you draw a bigger diagram. 225 is in this direction. We know that the north is the direction that is shown by the local meridian. So from there, if I measure clockwise by 225, I get exactly the same track. So this is a track of 2 to 5 degrees. Now the point B is somewhere along this particular track, and to understand where point B is, so to fix the point B, they have given that point B is 100 nautical miles from point A. So having that particular understanding, we now know that point B on a track of 225, 100 nautical miles away from A, will eventually put point B on a new latitude as well as on a new longitude, which is right here. Okay, which we are required to find out. So they're asking us to find out the value of this particular latitude as well as this longitude, which is eventually the position of point B. All right, now come back to this question here. So if you look at the question here, look at the options, right? So I want you to particularly pay attention to this particular these options here. Take some time and now try to figure out if you can actually find the answer in a different way or what. Right, I'll leave you kind of somewhere around here. You can take your own time and try doing this. I'll keep monitoring the chats, and if you really have confusions on how to have the final part of it solved, we will definitely discuss that as well. So as of now, I'm kind of leaving you with whatever time in your quiet space over there. Try finding out the answer. So basically you have the angle at the moment, you just have to find the sides, and then once the sides are known, you'll be able to find out lat and long. That's it. So I'll see you with another video, probably with this continuation of the same video if it is required. And we are kind of looking into a couple of questions from departure and convergency as well. All right, so that's it. Have your own space usefully used and try to find out the answer. From the you have 3 different options, A, B, and C. All right, that's it. I'll see you with the answer very shortly.